Alright, yeah, let's get started. I think I'm all good. I got all my windows up. I'm actually on time. Look at that. That's amazing. I'm actually pretty early, but yeah, so I'm all set up and we're going to just hop right into it. Today we're going to be looking at we're going to be continuing on what we did in the cleanup video, so episode 14 I believe that was, where we looked at the model class, and we're actually going to be integrating that class with the Assimp library, which we installed in the previous episode, so episode 17. It's a video that's up. If you haven't watched that, make sure to go ahead and do that so you actually have the library installed. So for today, I just wanted to first get a quick overview of what Assimp was, and then also we'll look at the inner workings, how it stores data, and then after that we'll actually look into how to implement the code in the model class, and then we'll be kind of modifying a bunch of different files to add for compatibility, and we'll actually be downloading our own our own models from an online site, which will be super cool. Alright, so let's get started. Assimp in itself, the way it kind of takes in data is it kind of creates something that looks like this. So it has a scene, and that's like the highest object in the hierarchy. And then what that does is the scene contains a few things. It contains a root node, and the root node is essentially like the first node in a tree, and it has pointers to children nodes, which also have pointers to children. It also has a list of meshes, so that can be referenced, and then also a material list, so that'll be something like textures and also just plain materials that we've actually been looking at. So yeah, that's the scene. Then the root node itself has other children, so it's like a tree structure, and then it has a list of meshes, but these aren't just meshes, these are references to meshes. So they contain indices to certain meshes in the actual mesh list in the scene object. And then each of those child nodes have the same thing, more children. Now each mesh has a vertex list, which we're familiar with, a normal list, which we are also familiar with, texture coordinates, familiar with. Now faces is something that we haven't heard of, but it's exactly, we actually are familiar with this. It's just the sequence of indices. So each face is composed of 3 indices, so this will just store the indices of the vertices to draw in which order, and then it also has textures, material indices, and stuff like that. So yeah, we'll look at how, when we actually write the code, a lot of this will become more apparent, and how it truly works, but yeah. I guess we can get started. So yeah, make sure that you have the library all set up. I just had to redo that quickly. I was running into some issues, but now it's all looking good. Alright, so we will start in the model header file, and we'll define a bunch of new methods here. So the first thing to do is, let me find my reference here. Alright, first thing we want to do is actually add the includes for the library. So we're going to start with include assimp / importer with a capital I .hpp, include assimp / scene.h. Let me actually just see how loud this is. Give me 2 seconds. This might be a tad loud. I think it's looking good. Alright. And then the third and final include will be include assimp / post process.h. These are going to be the 3 files that we'll need access to actually load in a model properly. Okay, the next thing we want to do is we're going to use the values from the cube class. So we have the position and the size in the cube class, and we will just want to put that in the model class because we want to generalize that for all models, not just the cube. You can just put that under meshes wherever you want it. I'm going to have this here, glm vec3 pose and glm vec3 size, and then we also want to create a new constructor to actually so that we can initialize an object with this. glm first parameter will be the position, which will have a default of 0, or default of 0 with the 0 vector. The size will have a default of 1. And that's that for the parameters for now. Keeping it as is because we want to have that inherited. And then we're going to have one more method in the public sector, and then we'll move into the protected sector actually. Okay. Other method will just be void, return type of void, and the name is load model, and we will pass in a standard string for path. Just like that. Now for the protected stuff, I actually want to move the mesh list into this protected area, because I want to be able to access it in child classes, but not as a public member. Then I also want a standard string for the directory, and this will just point or have the value of the directory that contains the model file. Then we are also going to have a list of textures that have been loaded. Standard vector, and we will have texture, which is an object that we created, and we'll call it textures loaded. This list will just allow us to optimize some of the loading a little more, just so that we don't load the same textures twice. Now we're going to have 3 methods. First one is void process node. First parameter is AI under lowercase, then node pointer node. That's the essentially this will be each node in the Assimp library. Then const AI scene pointer scene. So this will also just be a reference to the general scene, because remember, we want to have access to the mesh list and the other lists that are contained in this scene. Then return type of mesh, process mesh, pass in AI mesh pointer mesh, then const AI scene pointer scene once again. And then the next thing is to load the textures. Return type of standard vector of type texture, load textures, AI material pointer, mats, and AI texture type. Okay, so those are the methods that we'll have, and we'll be implementing these. But I first wanted to go to the texture class and actually just kind of wipe it clean. I'm going to be 100% honest, just because a lot of these methods are completely just unnecessary, I'm going to say. What you can do is take the set filters and set wrap method, we can just delete those. It's not going to be necessary anymore. Then we can also delete everything under bind, and we'll redefine some of those, but for now we just keep bind there. So what you should have now is just the 2 constructors, the generate method, the load method, and the bind method. We also want to change the path for the texture, or the parameters for the texture constructor. Just change it to standard string directory, standard string path, and then AI texture type. And for some reason that is already included, but just to be sure, we can add an include for assimp/scene.h. So AI texture type is a class, or I believe it's either a class or an enum, maybe. It's an enum, yeah. and it's just the type of the texture that Assimp has loaded in actually. Okay, now under bind we want to add some variables here. We will start with the ID, unsigned int ID that we have seen so far, or that we had. Then we want to store the type, AI texture type, then standard string directory, and standard string path. Okay, now in texture.cpp, we're going to do a few things here. We're going to take out a lot of this code here. We have our default constructor. Now we just have to, I'm going to start from the top. So delete the static variable, it won't be needed anymore. Then delete the constructor that has the parameters. And we're going to redefine it using the function signature that or the constructor signature that we just defined in texture.h. And what we want to do in this is we're going to have an empty body, but the initialized list will set dir to dir, path to path, and type to type. Now we'll generate. We want to instead we just want to change it GL gen textures and just change it to a reference or one and then a reference to ID. And you can also delete the second line that says GL bind texture, not needed. Now in load, there's another thing that we want to do. Since we deleted the global or the class variables for the path, the width, the height, and the number of channels, we have to define some of those. So towards the top, just say int width, height, and number of channels, and that will remove these errors. But then for the stbi load, what we have to say now is, since we only have a directory and a path, we have to concatenate those, and then get the C string. That's going to be dir plus then a slash plus path, then make sure that's all in parentheses, and then say .c string. And then underneath where we actually need to set the filters. Now I'm just removing those functions just because they're cluttery, and we never deviated from the default parameters. So we can just define those underneath the loading. So after where we say GL generate bitmap, we're going to have the 4 parameters. I will actually just copy them from the set filters and set wrap method. We just have the texture mag filter, texture min filter, and then wrap s and wrap t. And I will tell you which parameters to use for each. For wrap s, we want to use the GL repeat, and for wrap t also do GL repeat. Then for the min filter, we want to say GL linear mip map linear. I started on my words. It's GL linear mip map linear. And then for the mag filter, it's just GL linear. And then you can delete the functions. So once you have those in place, you can delete the 4 functions that we use to set the filters and the wrap. Alright, that is the texture class. That's all. We drastically just got rid of a bunch of unnecessary stuff. And now that we have this in place, we can actually go into the model class and start writing the Assimp code. Oh, one sec. God damn. I think I'm going through like middle-aged balding just because my fucking hair is falling out. Every time, I don't know. It's just weird shit. Maybe I am middle-aged and you just don't know. Alright. Yeah, so now we can go into model.cpp and we'll define the source code here. What we have now is very basic stuff. Yeah, so we'll just go from the top of what we changed. Let's start with the new constructor. That's just going to read model ::model, pass in glm vec3 pose, glm vec3 size, and then just initialize both using initializer lists, pose to pose, and size to size, and then an empty body. Init we can leave empty. Render we will leave like this for now, but we will be changing that in the future. Okay, so go underneath cleanup and let's start actually defining these functions. We'll start by saying with the load model, return type of void model : load model, standard string path is the only parameter. We're first going to actually create an importer here. Assimp : importer import. This will just allow us to actually import this is kind of a class that allows us to read files. Then we're going to say const AI scene pointer scene is equal to import.read file, and we will pass in a few parameters here. Path, and then for the flags we're going to have AI process underscore triangulate, and then bitwise OR that with AI process flip UVs. I will explain those in a second. You will, oh, that's nice. Vswash. SFML. Isn't that that's an OpenGL, or I think that's an OpenGL library. That's cool, yeah. I don't know, I kind of tossed myself in the deep end here, going straight to the low level. But, you know, I enjoy this, it's pretty fun. Yeah, for the flags, the triangulate just says group the indices in threes, so you make triangles, and then flip UVs is exactly the same as what we do in texture, where we say stbi set flip vertically on load. And I actually forgot to pass in the parameter here. In texture load, it should be, you should pass in stbi set flip vertically on load, and then pass in the flip, not just true all the time. And we will actually be passing in false for load because we tell Assimp to load it in right there. Yeah. Now we just want to have a checker, just to make sure it was loaded properly. If not seen, so if the pointer does not exist, or seen at m or .m flags, bitwise and with AI underscore scene underscore flags underscore incomplete, and then that or not seen .m root node. There are three possibilities here to see if the importer was not read, or the file was not read properly, if the pointer does not exist, if the pointer to the root node does not exist, or if the flags mean that it's incomplete. Then we can just print out here standard cout could not load model at path, and then standard end line, and then we can just actually print out an error string by using import.get error string, and then another end line. And then we can return after that. Outside of the if statement, we want to get the directory. Directory is equal to is equal to path.substring. We're going to use a C++ method here from 0, and then the size will be path.find last of, then the slash. And then process node scene dot m root node, and pass in the scene as well. So we will start just by passing in the root node into the processing, and if you work with trees in general, you know that if you're going to if you're going to call any method to process a node or the tree as its whole, then you will start by passing in the root node, which will then recursively call the same method on the child nodes. That's just a general rule of thumb there. Now for the second method, process node actually. Return type void model process node, AI node pointer node, and const AI scene pointer scene. We first want to process all the meshes. It's simply going to be for unsigned int I is equal to 0, I is less than node dot m number of meshes, then I plus plus, then AI mesh pointer mesh is equal to scene dot m meshes, and then we want to get the mesh at the index of node dot m meshes at I. So each node has a list of indices of meshes, and the indices will point to the mesh list here that's in the scene. Then we want to say just meshes, so the mesh list in the model class dot pushback process mesh mesh and scene. So we will then pass the AI mesh into the process mesh function, which will then return a mesh class which we defined. Then we want to process the children, and you might recognize this as post-order processing, where you process this is pre-order processing, where you process the values at the current node, which would be the list of meshes, and then you go to the children. So process all child nodes. Pretty much the same thing. For unsigned int I is equal to 0, I is less than node dot m number of children, I plus plus, and then we just want to call the method recursively process node and pass in node dot m number of m children, sorry, at I, and then pass in the scene. So here the node actually contains pointers to the children themselves. It doesn't contain indices because the scene does not have a list of nodes. It just has the pointer to the root node. Okay, yeah, so that method's pretty simple. Now for process mesh, it's going to be a little beefier, but a lot of this should be relatively, I'll say relatively familiar, or somewhat familiar. Yeah, because we'll be generating a vertex list essentially, and we'll be going through the textures, which we have seen most of. Alright, return type mesh model process mesh, pass in an AI mesh pointer mesh, and const AI scene pointer scene. We want to have our list here, so standard vector of vertex, which is the struct that we define in the mesh.h file. Vertices, standard vector of unsigned int indices, and standard vector of textures. If you notice or recognize these are the three things that we need to pass into the mesh constructor. The vertices, the indices, and the textures. And then we'll populate them and use them to create a mesh. Alright, this will be pretty standard. We'll be going through each vertex, processing the coordinates and the values, just like we do in vertex.gen list here. It looks somewhat similar to this. Okay, model.cpp. You coded a compass and a rush? Oh, that's fucking amazing. Dude, I fucking love coding compasses. And especially when you have to rush. God damn it. I hope that code doesn't tarnish anywhere. That's an inside joke, by the way. I forget where, but I just, for those who don't understand what I'm talking about, it's an inside joke. I actually don't know if I can find that, to be honest. I doubt I can. I've tried it, but I can't. It's a Snapchat commercial, if you're wondering. Alright, we will go through each vertex with a for loop. So for unsigned int I is equal to 0, I is less than mesh.m number of vertices, I++. We'll have a vertex, just to contain the values here, and then we'll set the position, the normal, and then the texture. For position, we'll start with vertex.pose is equal to glm vec3, and then we'll just get the x, y, and z values of the vertex. Mesh.m number or m vertices at I.x, mesh .m vertices at I.y, and mesh.m vertices at I.z. Normal vectors, same thing. Vertex.normal is equal to glm vec3, mesh.m normals at I.x, mesh.m normals at I.y, and mesh.m normals at I.z. And then for the texture coordinates, we actually have to have one extra thing here. If mesh.m texture chords add 0. Now, what does this mean? So texture coordinates, it doesn't just store pairs of coordinates here. It stores it stores like a list of textures. Or I forget how to explain this, but essentially Assimp loads in several different sets of texture coordinates, and certain textures correspond to certain meshes, or there could be multiple textures with a mesh, but we're only going to load in the first here. So if the 0th texture exists, we're going to load in a texture as what it gives us. So vertex.textchord is equal to glm vec2 this time, because we only have an x and a y coordinate. And then the elements will be mesh.m texture chords at 0 at I.x, and mesh.m texture chords at 0 at I.y. And then else, we're going to say vertex.textchord is equal to glm vec2 of 0.0f, because we still need to have something there. And then after that, we can just push it to the list. Vertices.pushback vertex. And then after this, we can also go ahead and process the indices. So for unsigned int I is equal to 0, I is less than mesh.m number of faces, I++. Then AI face is equal to mesh.m faces at I. So this is just loading in the face, which is essentially just the pair or triplet or quadruplet of indices, but because we told Assimp to load in triangulate this flag here, it will load in them in triplets. Here we're going to say for unsigned int j, make sure it's a j is equal to 0. J is less than face dot m number of indices j plus plus. Then we're just going to say indices dot pushback face dot m indices at j. So we essentially just push back each index to the index list. Okay, now for the material, that's the last thing in the mesh here. We're going to say if mesh dot m material index is greater than or equal to 0. That means that there are materials to be processed. We're first going to get the material pointer. AI material pointer material is equal to scene dot m materials at mesh dot m material index. So each mesh has an index of what material it is, which points to a certain material in the scene's list of materials. Now we're gonna this stuff we already know. We're gonna be loading in essentially diffuse maps and specular maps. Now there are a couple, but we can just load them all in separately, and we'll get the type, and then also the wait, am I saying this right? Yeah, but we're going to load in the diffuse maps first, and then the specular maps, and then we'll push them both back. Alright, with diffuse maps, we're going to say standard vector of texture diffuse map or maps is equal to load textures, and we will pass in the material and then AI texture type underscore diffuse. Then textures.insert textures.end. So we're just going to insert the entire list using this function here. And then diffuse maps.begin and diffuse maps.end. Then same thing for the specular maps. Standard vector texture, and we'll call it specular maps, is equal to load textures, material, and then AI texture type, specular. Then textures.insert textures.end, so at the end of the list, and then we'll insert from specular maps.begin to specular maps.end. And then outside of the if statement, we just want to return the mesh with the lists in them. Return mesh, and we'll pass in vertices, indices, and textures. So what we did in this method took a little bit, but essentially all we did was we populated the vertex list, the index list, and then the textures list, and then we're going to pass them onto the mesh class, and we have already written the bulk of the code we've actually written all of the code to process these and send the vertices, the indices, and the textures to the GPU. Now for the last method, it's going to be pretty simple. Standard vector texture model : load textures, pass an AI material pointer maps, and an AI texture type. So we'll have a placeholder here, standard vector textures, and then you can just say return textures at the end, just because I sometimes forget to do that. Now we're going to iterate through essentially each texture. Assimp makes this super easy for us. All we have to say is for unsigned int I is equal to 0, I is less than mat dot get texture count, and we'll pass in the type, so it gets the number of diffuse textures, the number of specular textures, the number of whatever textures, and we will be adding some more in the future. Then I++, then we're going to get a string here, AI string, so we're not using standard string, we're going to say AI string, str. We will say mat.getTexture, pass in type I, and then a pointer to the path, which will be, or a reference to that, so it can store the value of the path here. And then we can also just print this out by saying standard cout str.c underscore str std and l, and we'll look at what this outputs when we run this in a bit. Then we also want to take advantage of that of the loaded textures list that we have, so just to prevent duplicate loading. So we'll have a boolean skip is equal to false, just to determine, and we're going to try and prove this. We're going to try to, because so what we do is we assume that the texture is not already in the list, but then we want to kind of prove that false. So we'll go through each element in the list, and then we will essentially compare each one. So for unsigned int j is equal to 0, j is less than textures loaded dot size j++, if standard strcmp, so we're going to use a string compare function, textures loaded at j dot path dot data, so we're going to get the data of that string, and then we're going to compare it to string dot c string. So it's a capital C here and a capital S with the function, just because that's the AI string. And if that comparison is equal to 0, then they are the same. So we're just going to say textures dot pushback, and we will pass in a copy of textures underscore loaded at j. So we're just going to pass a copy of the already loaded texture. Then skip is equal to true, then break. So we have proved this false, so we have proved this assumption false, and we can skip loading it again. All we have to say now is if not skip, we will go into here, and it's not loaded yet. So texture text, and we will initialize it with directory. That's the path here, which we get from the model class, I believe, or oh yeah, that's from the model class. Then string dot c string, and then type. So essentially, string dot c, or this string will return the path relative to the model file itself. So we're going to concatenate that with the directory of the model. Then text.load, and we're going to pass in false for flip because we don't want to flip it. Then we want to push it back to the loaded textures list so we don't duplicate it. So textures.pushback text, and then also textures underscore loaded dot pushback text. Alright, that's the model class, and then we return that at the end. Yep. I'm going to refill my water. Just take a look at that, and I'll be back in half a second. was fun. But yeah, that's pretty much most of what we will use Assimp for. We're just going to use the one more structure from it for color values, but we'll be doing that later on. We still just have a few things to actually get through, and then we'll be getting to that. Alright, the next major difference here is going to be, or the next non-maintenance difference, because this is something that the next thing that we're going to be changing is in the mesh render function, and this is actually going to be something that requires intelligent thinking, or some algorithmic thinking rather. It's not just going to be moving code around. We're actually going to be writing some new code here. So in mesh.cpp, go into your render function and actually delete everything. Delete the textures part. We're going to be rewriting that. So you should have the bind VAO draw elements bind 0 and then activate texture 0. All right. For the textures, the way we're going to kind of load the diffuse and specular textures in is going to be, we're going to kind of have, because we want to load both of them in, and we're going to load, I don't know how to explain, this is going to be a little rough to explain, but essentially we're going to have an index for the diffuse textures and also an index for the specular textures. And this name will be coding in here, and then we will have to correspond the names in the fragment shader to actually load it in properly. So we'll start with an index. So unsigned int diffuse idx is equal to 0. Then unsigned int specular idx is equal to 0. Then for unsigned int I is equal to 0, I is less than textures dot size I plus plus. You can also take the size first and then just compare it, like just by creating another variable, but I have this in the reference, so I'm going to keep it like that. First thing we want to do is activate the texture slot, the texture unit, and we've done this already. This is stuff that we're familiar with. GL active texture, pass in GL texture 0 plus I. So just activate the ith texture slot, so we can have a maximum of, I think, what is it? GL texture 6. Oh wow, that's a lot. Okay, I guess it's, you can have a maximum of 31 textures per model until it just kicks you out. But yeah, so we're activating the ith slot, and we want to retrieve the texture info. So standard string name. Then we're going to have a switch for the type. Switch textures at I dot type. Case AI texture type underscore diffuse. And if it's this, we'll say name is equal to diffuse plus standard toString diffuse idx plus plus. So what we're doing here is we're taking the name diffuse, then we're going to take the diffuse index, convert it to a string, and then increment the index so it goes 0, 1, 2, and so on, and then break. Otherwise, we're going to say case AI texture specular, and name is equal to specular plus standard toString specular idx plus plus, then break. Oh, AI texture type. And this is entirely expandable. So if we had another type, I believe, well, we might be doing normal, or not normal, depth mapping. No, not depth mapping. I'm sorry, parallax stuff with textures, and that involves this stuff too. Then we want to set the shader value in the texture, or in the shader. Wait, sorry. Set the texture value in the shader. shader.set int name and I, then bind the texture. So textures at I.bind. And then we draw it and we're good. Now, I believe that's good for there. The next thing we're going to want to do is actually implement this in the shader. So go into object.fs, and I'm going to have a fun time trying to parse this out. First thing we want to do is just change back the sampler, the diffuse and specular elements in material to vec3s. Because we're not going to be using the structure anymore. We're going to have the sampler values as just separate uniform. So for the model that we're going to be loading in today, or that we'll just have one diffuse texture and one specular texture per mesh. And you might see it different, but it's all dependent on the program. So you could implement this where there's an array, and you pass in the index of the texture during each mesh, something like that. So we'll say uniform. So outside the struct, we'll say uniform sampler 2D diffuse 0, which is the first index. Then uniform sampler 2D diffuse or specular at 0, specular 0. Now once we have these in place, we just have to update the diff map and spec map to say the texture, instead of saying material.diffuse, say diffuse 0, and instead of material.specular, say specular 0. And everything else should be on point. Yeah, everything in the shader is on point for now. Then the next thing that we want to do is we're gonna have just two more quick things to do. In the cube class, we're going to have a couple of errors here, I believe. Let me just make sure this. So you can go ahead and delete the default constructor, and also delete both constructors right now. And instead, we're going to have a new constructor, cube, where we'll pass in a glm vec3 pose, which is equal to the 0 vector by default, and a size vector, which is equal to the glm vec3 1 by default. And then in the initialize list, all we want to do is just call the super constructor by just saying model, pass in pose and size, and then an empty body. And then for the textures, since we updated the structure, just comment them out. We're not going to be using them yet, or we won't be using them right now. Nope. And then what you can also do is in the mesh constructor, you can make the texture parameter default to an empty initialize list, just so we don't have to pass in a texture list. So that's just equal to an empty initialized list, and that will help us with the cube class where we don't want to pass in these textures anymore. Then for the render class, or the render method, you can actually just remove it, because we will simply be we'll just be relying on the model render method now, and we'll be moving in the model matrix calculation to the model class, which is actually, we'll do that right now. So once again, I want to use the model class to kind of generalize for all models, not just cubes. So in model.render, above where we render each mesh, we want to generate the model matrix. So glm mat4 model is equal to the identity matrix, glm mat4 1.0. Then model is equal to glm translate model and position. Then model is equal to glm scale model size. Then we can rotate it, or leave it without the rotation for now. And then what we want to say is shader.setMat4. Pass in the model name and then the model matrix itself, and then the shininess will just be shader.setFloat material.shininess and 0.5f. Just like that. Okay, so now we have we have everything we need. We're going to use the models now. So in the description I have 2 links to some models here. They're on a site called Sketchfab, which is good for a bunch of free models. There's paid models, but it's mostly free. I found this cool model, and it's made by Oleg Gunnar. I'm going to axe his name, but either way, just click the download 3D model link and then click auto converted format GLTF. Assimp is able to load a bunch of different models, which is pretty nice. So we can just have the GLTF file and just load it in. So I already did that. And then in your assets folder, I recommend creating a models folder here. Did I? Yeah. Create a models folder here. And then in the models folder, drag the zip files, or the zip file, sorry, and unzip it. Extract it to whatever it is, and then I would recommend just renaming it to LOT, what do I call it? Sorry, what did I call it? Huh, well, give me 2 seconds. Oh, here we go. I called it LOTR_troll. So I just got rid of the last 2 words. So it should be like that. So you can delete the zip file. So now it's in here, and all we got to do is in main.cpp now. You can get rid of the cubes because we're not going to use those anymore. So the cube array that we had, just let it go. I don't want to start singing that song, but delete it, let it go, whatever you want to do. Throw it in the trash maybe. But we're actually just going to go ahead and create our own model here. We first have to include the model class because we haven't. Include graphics/model.h. And then to initialize the model, we're going to use the constructor model m, and we'll pass it in with we'll just leave the default parameters, and then m.load model, and we will pass in the path as assets/models/LOTR_troll/scene.gltf. Just make sure whatever model you have, make sure that this path is relative to the what did I? Yeah, just make sure it points to to the GLTF file. For me, it's giving me an error. Okay, I guess you can delete the default in the model class if you haven't already. You can delete the constructor with no parameters, because the constructor with the default parameters is also considered a default constructor since it has no explicit parameters or no required parameters. Okay, that's good. Now in the main loop, just get rid of the cube rendering, And all we're going to stay instead is m.render and pass in the shader. And then after, we're going to clean up the model. So m.cleanup. Alright, I'm hoping this works. You boys ready? Running. We're going to spawn inside of the trolley. Oh, great. Oh, I just didn't, I didn't delete the definition of the no parameter constructor. That's fine. Okay, if you get any, I got another error in the lamp class just because I updated the cube constructor. That's fine. Just delete the material parameter since we removed that, and then now we can run it. Oh my god! Holy shit, he's fucking massive. I can't go fast enough, he's too big. Alright, well obviously something needs to, I actually also think that this is wrong. But you can see how the lighting still kind of works. Let me make him smaller. So we'll pass in to the model constructor a glm vec30 for the position, or you know, let's say I want to put him, or what is our initial direction of the camera? I'm too lazy to move it, so I just want to have it directly in front of me. Camera.h. Camera front is -1 in the z direction, so we'll have them at 0 in the x direction, 0 in the y direction, and then -5 in the z direction. Then the size is, we'll just make it 0.05, so 1/20th. Now let's run this and we'll see what happens. Look at that. Okay, so this is, so you might be confused. So the textures I think are fucking up here. I need to fix that. But either way, that is this is a separate mesh. You might be wondering, oh, why am I not seeing it on him? Well, they're two different meshes. So if when we do animation, we can put that on him. Okay, I need to figure out why this is. But you can see some of the specular stuff actually taking place, which is nice. So it seems like the I may have screwed something up in the mesh. But at least it's in there, right? This just has to do with the textures. Diffuse IDX 0, specular IDX 0, textures.size activate 0 plus I, name, textures that switch at the type diffuse goes to diffuse plus diffuse IDX plus plus, specular blah blah blah, set int name I, bind. Okay, that looks right. Maybe the texture loading. No, it said that it loaded both. Maybe. Oh. Holy shit, that looks like a fucking fever dream. Yeah, we load that. Yeah, it tells us that. Okay, so these are some of the other textures that you might see, by the way, and we might get into some of these at some point. But what? Textural emissive. It tells us which textures it's loading. That's the thing. And it printed them out nicely, and it printed them out twice, which may actually, okay, that's Oh, the sun is moving. I forgot we implemented that. Yeah, textual base color. Is that right? Text troll base color.jpg. Yep. And then text pants base color.png. This is very, god damn it. Let me try printing out the skip just to see if it just see what it skips. So we should see a false 0, 1, 0, 1. That's right. Okay. So that's good. Now let me see. All right, let me actually go into mesh and see what it wants to render. Or actually go up here. Let me remove the lamp rendering just because I don't want to have a breakpoint there, but I'll still have the lights being like rendered in the shader. Okay. Diffuse IDX textures. Diffuse base color. Troll base color. That doesn't seem right. Unless or wait, no, we're rendering the troll, so yeah, that's fine. So activate 0. Name is equal to blank. Name is equal to diffuse 0. Good. Break. Shader.set int name I textures.bind. Diffuse 1, okay. Let me see what the IDs were, I forget. This is great. So the type is diffuse, but the ID is that. That does not seem right. Although I don't think that matters actually, because it has been working. Alright, it has to be with shaders not activating then. That could definitely be the problem. No, we say shader not activate up here. But the other thing is let me breakpoint here then. Alright, model. So yeah, good. Set the mat for model. Then for each mesh, we have 2 meshes. So the first one is going to be the troll itself, and then the second one will be the fucking the caper is crotch cover. So the first mesh is the larger one. Troll itself. This is what we got into, right? Troll base color. Yep, that's right. Okay. And for the second mesh, we have textures that eye is the pants base color. Okay, that's right as well. So why is it not? What the fuck? Okay, I think I was getting this error actually. It had to do with something, but I do remember this happening, so I'm just gonna move on. But there's something that I know is that I will definitely fix in the next episode. Definitely, completely, 100%. Okay, so that's the bulk of the tutorial, and now we're gonna have one extra specification here, or one extra part of the algorithm, because there is actually a second type of model. The first type that we have right now is this here, and more model information. See, it has 11 textures and 2 materials. And then there might be some models like this low poly M4 by Tasty Tony that have no textures and only materials. So Tasty Tony is known for his work in the industry. He makes a bunch of low poly assault rifles here, which actually look fucking sick. I'm just gonna say now. You can do a lot of fun stuff on this site here, and they're all free too, which is nice. I believe I'm not sure what the crediting actually is. I might be getting shot in the foot because I don't have a credit in the GitHub. Licensor, under the following terms, you must give appropriate credit. Provide a link to the license. I might want to do that. I will put that in my GitHub page, or in the repository page. But either way, point is, no textures at all. So we have to create a way to load in. Now, if we were to say load this model in, I have it up. I have it right here. I'm going to extract it. Make sure that's the scene.gltf and scene.bin. Notice how there's no textures folder. Then we're just going to say M4A1. Now if we were to load this in main.cpp, I'm going to remove the breakpoints actually. Then in main.cpp, if instead we loaded at the path models M4A1 and ran this, you would see this, and because it doesn't know what to load. Well, it's not that it doesn't know what to load, but it has just 0 values. The textures are all 0 because there are no textures, so it just loads in the default, which is just a 0. The shape is still there, so it's just the colors that aren't being affected. But it's a cool little, nice little model here. I will actually re-render the lamps so you can see that even with the lamps there's no difference. So we actually have to this is going to be the more annoying part because we have to change a bunch of naming, which is going to suck, but we'll start in the model class, And here we're just going to add a Boolean to say whether or not we have textures. So it's a protected value. And we'll say bool no text. And then we'll pass this in the constructor. Bool no text is equal to false by default. Then in model.cpp, we want to add this to the constructor. And so bool no text, and then put it in the initialized list. No text goes to no text. Then in model.cpp, we have to add one thing in process mesh. We have to, since we don't always want to load textures, we have to do something here. So above where we, or in the if statement, so if mesh.m texture records at 0, if that exists, in the process material, after we get the material pointer, we want to have an if statement. If no text, then in curly braces, we're going to get the diffuse color. So this is stuff that we like what we have in the material.h file. So we're essentially going to be getting all of these values here, but they're going to be in the model file itself. So the diffuse color will be an AI color 4D diff, and we'll just initialize with the 1.0. This is like a 4D vector. And then we're going to say AI get material color, material, then AI underscore mat key underscore color underscore diffuse, and then a reference to diff for the output. Then the same thing with the specular color, AI color 4D spec 1.0 float, then AI get material color, material, and AI mat key color specular, and then a reference to spec. And then at the end, instead of returning a mesh with textures, we want to return a mesh with color, with material colors. And I'm just going to write this, I'm going to put the function call right now, but we will add the constructor in half a second. So return mesh, pass in the vertices, indices, that doesn't remain, or that doesn't change. And then we're going to pass in diff and spec instead of the texture list. Now it's going to give us an error because we don't have a constructor defined like that. All we have to do though is in mesh .h, we want to add a private value, bool no text, and this will just be the Boolean value for if there's a texture or not. And then we will also have a value underneath the texture list. We'll have two colors, AI color 4D or diffuse, and AI color 4D specular. And the includes are brought over from the model, or from the texture. Where are they brought in from, actually? I don't know, but they are brought in somewhere. If you get an error, just include the AI scene, I believe. All right, now in mesh.c, or now we want to have the second constructor here. So mesh will have the standard vector of vertex for vertices, standard vector of unsigned int for indices, then the AI color 4D diffuse, and AI color 4D specular. Then copy this function signature over to mesh.cpp, and just we'll have the same initializers for the vertices. So vertices goes to vertices, indices goes to indices, but this time we're going to have diffuse going to diffuse, specular going to specular, and then we also have the Boolean value no text go to true, because we want to specify that there are no textures. And then in the first constructor we'll say no text is false because there are textures. And then make sure you have your class tag in there. And then we also want to call setup. which is just the function to load up the VAO and stuff. Alright, let me make sure I got everything there. Yeah. Okay, now this is going to be the annoying part. We're going to have to change, since these are loaded in as 4D colors, we're going to have to change pretty much all of these values. And this will be helpful later on when we actually want to add transparency to objects. So doing it now will just save us the pain later. But this is going to be the worst part. So we will start in the shader class by adding a function to set a 4D vector. Shader.h and shader.cpp. In shader.h, just add above the set4 float, or below it, either one. Just add another set4 float, the const standard string reference name, but pass an AI color 4D color, and this time we have to add the include assimp slash scene.h. And then we can also have a void set4 float, the const standard string reference name, but passing in a glm vec4 v. Then for the shader.cpp, for the definitions, we will just call the set4 float, just passing in the values individually. So for with the color, we're going to say we can say a GL uniform 4F GL get uniform location ID name.cstring, and then the 4 values will pass in our color.r, color.g, color.b, and then color.a, which is the RGBA. So that's why we need 4. And then for the vector, we're going to say, make sure you add your shader tags to the functions too when you define them. Then for the set4 float with the vector, we're going to have the same first parameter, but instead of the color.rgba, it's going to be vector v.x, v.y, v.z, and v.w. Those are the 4 components. Alright, so that's the shader class. Now, this is going to blow, but in light.h, we just have to change all the 3D vectors to 4D vectors. Well, not all of them, but all the ambient, diffuse, and specular. So what I'm going to do is I'm going to change the first one to glm vec4. Then I will copy the vec4 and paste it in the ambient, diffuse, and specular for each of them. So just double clicking the vec3 will select only the vec3 and the ambient, diffuse, and specular. Just a quick way to do that. Now in light.cpp, we have to change a lot of this shit as well, because instead of setting a 3D vector, we're now setting a 4D vector. So instead of saying set3 float for the ambient, diffuse, and specular, just say set4 float. So you should have a total of 9 switches in both the source and in each of the source and header files for the light class. So that's the light. Now for lamp, it's I believe this is quick because we just have to change the values or the type or the variables in the constructor just to be 4D vectors. So the ambient, diffuse, and specular become 4D vectors now. Then in the object fragment shader, we have to change a lot of stuff here. We will start in the material structure by changing the 3D vector for diffuse and specular to 4D vectors, and then we can also get rid of the ambient value because we don't have that anymore. Then once again for the ambient, diffuse, and specular, the vec3s become vec4s. So for the three light structures that we have in our fragment shader, just change those from vec3 to vec4. Now we also want to change the return type on the calc light, calc point light, and calc spotlight to vec4. And then we have to, for the diff map and spec map parameters, change those to vec4 as well. So once again, you can double click to select the vec3 and then just control V with the vec4 copied, and that will make it easier. Now in the fragment shader, we are going to first do one thing. So delete the code where we get the diff map and spec map, and we're going to replace it now. We'll say vec4 spec map, or yeah, diff map, and then vec4 spec map. Then if no text is equal to 1, we have to pass this in as a uniform. I forgot. So uniform int no text. So if no text is equal to 1, we're going to say that there's no textures. So diff map is equal to material.diffuse, and spec map is equal to material.specular. And then else, we're going to say text diff is equal to the texture diffuse 0 at text chord. And note now how we don't have to convert this to a 3D vector because texture returns a 4D vector. And then, sorry, I said text diff, it's diff map and then spec map is equal to texture diff specular 0 and text chord. Oh, did I forget to do something? Oh, I did forget to do something. Okay, I'm going to put the replacement of 4D vector on hold for 2 seconds, just so we can go back to the mesh class, because I forgot to actually set or account for the new change. So we have the values in here, but in mesh.cpp, it's still telling us to render as a texture. So what we have to say here is, in the top of render, we're going to say if no text, then we're going to get the materials. So shader.set for float material dot diffuse. We're going to pass in the diffuse color, which is the AI color 4D. Then shader.set for float material dot specular, and pass in specular as the color, as the 4D color. And then shader.set int no text and set that as 1. And then in the else body, just take all the textures loading, so the diffuse and specular index, and then the loop, and then just put that in the else body, but make sure once again that you have the VAO binding and below outside of that. And that's it for the mesh class. Yeah, so just key thing is we're just adding the if statement to determine if we should set materials or textures. We were in object.fs. Okay. Next thing we want to change in object.fs is the result. Make it a 4D vector. Just find it. And then at the end of the main loop, instead of saying frag color is equal to the vector 4 of result, we can just say frag color is equal to result. Now next what we have to do is we have to go through the 3 calculation methods and change the certain references of a 3D vector. So first thing you can do is just change the return types and the diff map and spec map types to 4D vectors in all of them. That's just the easiest one to start with. So essentially any reference to a color now becomes a 4D vector. The index, or the normal vectors and the view direction will stay the same because those are still in 3D space. We're not moving those to 4D space. And then essentially all we have to do now is in each of the calculation methods, make the ambient, diffuse, and specular components all vector 4D vectors. and then return a vector 4 of the sum. So once again, in calc point light, we're just going to change ambient to a type vec4, diffuse to a type of vec4, specular to a type of vec4, and the return type will be vec4, and that's times attenuation once again. And then for the calc spotlight, ambient becomes vec4, so that's outside of the if statement. Then inside we change the diffuse to vec4 and specular to vec4, and then we also want to return the vec4 of the sum. Okay, so I believe that's most of it. Now we can actually go ahead and in the model class, or in the main file. Oh, I forgot. We now have to change all the references here again. Yeah, so we have a lot of vector 3s here. We just have to change them to vector 4s, but because they're colors, we can't just have the same component, because then the alpha value will be a 0 or like a 0.05 or whatever. So we have to make it so that, for example, in the lamp initialization, where we say glm vec3 0.05, we have to make that 0.05, 0.05, 0.05, and then 1.0. So that's going to be a pain. So I will... If you're confused on what to change, you can look at the GitHub commit and just see exactly what I changed. So we'll start with the dir light. Yeah, I'm gonna put the dir light actually above here. So dir light will become vec4, and vec4, and then we'll say 0.1f 3 times, and then 1.0f. So just repeat the component 3 times, and then the last component should be a 1.0. This is gonna be annoying, I know. Then in the lamp, we want to do the same thing. So the 3 middle vectors that we set, so the ambient, diffuse, and specular, become vector 4s now. And the first 3 components become what we have. And the last component becomes a 1.0f. Like so, and then the spotlight is the same thing. So the 3 vectors on the bottom, just change them so that the first 3 are the color that we had, and then the 1.0 for the alpha component. I believe that's it. And then next, the last thing that we want to change, which actually matters, and it's not tedious, is in the model constructor we want to say no text is true, because in the M4 model that I downloaded here, we want to load in materials and not textures. All right, taking a breath. Let's run this. We'll see. Aha! Look at that. You can see the specular. Oh my, that actually looks super nice. But yeah, you can see the different colors. They're not enunciated that well, but you can see the specular values. It's not just black. You see the difference in there between the gray and the black. But then you also see the specular components now. Like, look at that. It's so nice. It's super fucking nice. It looks sick. It's almost like I'm looking through a gun. Look at that. Yeah, nice. Okay. So yeah, that's pretty much the bulk of what I wanted to say that I once again, that whatever you want to call it, the issue with the troll, I believe I fix. I'm gonna find a fix. I just don't want to do it right now. I'm too lazy, and it's getting late. I have work to do. But it's not too big of an issue. It's probably just a naming thing. But the algorithm itself is fine. In the next video, we're actually going to be looking more at something called a billboard. We're going to be looking at the gun. And how to actually have that follow the camera. So we'll be looking at a bunch more into transformations, orders, specifics there. So yeah, that's coming down the line. But this is also the last redo. So everything after this, the sound was already good, so I'm looking good. So next I will be going back into present OpenGL. We'll be finishing off the shadows and stuff. And yeah, so I really don't got much else. Play around with a lot of this stuff, honestly. Find some cool models. Maybe find a dildo. Let me try and find a dildo. I don't know if I can show this on YouTube, but I also don't want to take the chance. I see tentacle art, dodo aircraft. I see a penguin dildo. You know what, this is okay. We can just say it's not a dildo. Look at that. I need a 3D print. Oh, that's kind of weird, Toasty Engineer. But thank you, Sculpt Fab, for this. But, I mean, there's a lot of stuff that you can look at here. Holiday challenge? Yeah, I got some ideas of what to do in the future, or within the next month, because I kind of want to do some of my own model creation. So I might look at doing some Blender stuff with Santa Claus because it's Christmas time. But yeah, we'll see. But there's so much on here that's just looks fucking beautiful. And we'll be going later on. We'll be looking more into depth on everything that comes with all this stuff here. Look at that's pretty fucking cool. But yeah, I got oh, is that lo-fi study? Is that a 3D model? That's a 3D model? No fucking way. Should we download Lo-Fi Girl? That's fucking amazing. Holy shit, there's a Lo-Fi Girl 3D model. That's amazing. Alright, I'm gonna exhaust myself. Yeah, so read into this stuff. You can take a look at the Learn OpenGL page on Assimp if you're having a little trouble understanding it. Yeah, I don't know, just play around with this stuff. Oh my god, it's another study girl. Holy shit. That's so accurate. Holy, where's the cat? Oh, there's the cat. God damn, that's pretty cool. Yeah. I don't know, I don't got much else to say. So yeah, I hope you guys enjoyed. Hope you guys learned something. And yeah, take care of yourselves, and I will see you in the next OpenGL video. And yeah, have a good one.